My name is Dave Stokes. I'm a MySQL community manager for Oracle. Previously, I was the MySQL certification manager for MySQL AB. Then we got bought by Sun. Then we got bought by Oracle. No one's bought us in 8 years, so we're not feeling the love. If you need to get a hold of me, here's my contact information. By the way, if you're local and you live in town, on Tuesday, the 23rd, 7 p.m., over at the Samovar T-Bar is the annual MySQL reception that we hold during Open World. You do not need an Open World or an Oracle Code 1 badge to attend. It's 2 hours of free food and drink and a lot of interesting people. However, you do have to RSVP. If you follow my Twitter feed or you go out to my blog post, you'll find the invite in the RSVP page there. But it's free and it's a great time. So, what is this talk about? Well, I'm going to talk a lot about MySQL 8 features. MySQL 8's been out roughly for 6 months now. Our download rate is much higher than 5.7, which was our previous record holder. And I want to warn you, this is not a cookbook talk. I'm not going to tell you setting X to Z and get performance of Y. For those of you who really want that sort of talk, let me get this out of the way. The main recommendation I make to folks when they're setting up MySQL is the one setting to change is the InnoDB buffer size. Set it to roughly 75 to 80% of RAM. By the way, you can check that with this command to tell you what it is. By the way, how prevalent is this as an answer? There's even a cartoon on it out there that came out ironically today. So simple answers are very wonderful things, but most of us live in a more complex world where simple things just tend not to lead us down the path we want to go. What I'm trying to do today is move you up on Bloom's taxonomy. This is giving you knowledge to empower you to help you advance your career or advance yourself the way you want to go. At the very bottom is basic knowledge. You're kind of learning how to do things. Comprehensive is when you start putting things together, like Tinker Toys or Legos, you start building stuff out of them. And then in applications where you take those Tinker Toys and start being able to use them. That's where most programmers in their careers falter. If you saw Cal Evans earlier, this is the day-to-day programmer. Doesn't quite move up to the next step where you start being the rainmakers like Cal wanted to be. So hopefully this talk will move us a little bit further up that. So in the past 5 years, there's been a quiet database revolution. Most developers haven't even really noticed a lot of this going on. The big change for most of you that you probably noticed is cloud. What the dramatic change here is that you no longer need a DBA to go up and set up the database or the server, do the relations and all that fun stuff. If you're a startup, it's wonderful because there's very low barriers to entry, where before if you're setting up, you had to find a computer, a space for that computer, a network to attach to, someone to babysit the computer. Now that's all amortized. Also, the NoSQL world has really changed things. Ironically, you're seeing some of the NoSQL vendors like MongoDB now offering transactions, and most of the big database vendors offering JSON column stores. Also, the big change, especially with MySQL for the past 2 releases, has been security. Your bosses are really talking cloud and rapid development and all that, but they're spending their money on security. And lastly, something you're going to see more and more of, I'm going to touch on a little bit briefly, is as the hardware gets more diverse and virtualized and all that, all the software vendors who sell databases are getting better at telling their databases how to self-tune. It's not perfect, but it's getting there. And we'll talk about the benefits of that in a little bit. By the way, if you have any questions, please shout them out. I'd rather answer your question than have you not ask it and drag it home with you and have it fester. By the way, I used to be a stand-up comic, so heckling doesn't bother me. Upgrade. First piece of advice. Upgrade. Run the latest version of MySQL that you can. Well, why is that? Well, let me go into a minor rant, and you're going to have to excuse me here. Part of my job is going out and checking the various social media and other related websites to see what's going on with our community. And occasionally you'll see something like this on Quora.com or Stack Overflow. This is a bad exaggeration, but it's not too much of an exaggeration. You'll have a post where someone says, "Hi, I know nothing about brain surgery, but I popped open the skull of one of my coworkers in an attempt to kind of adjust their attitudes. How do you make those adjustments? What's all this red stuff leaking on the carpet? I have an IKEA Allen wrench, a screwdriver, and some duct tape. Please advise ASAP, as the coworker is kind of vital to production. And how do you clean a carpet? Now, for the sake of humor, I've really exaggerated stuff, but I often go out to the various question sites like this, and I'm absolutely flabbergasted on people are running something like MySQL 5.1, and they're trying to wonder, how do I get the JSON data type? Or they're running MySQL 5.5, and they're trying to integrate that server with an established replication set, and they don't have global transaction identifiers. It really helps if you can upgrade to the latest and greatest version. Now, that rant being done, let me flip 180 degrees. MySQL 8 came out in April, and we had someone on Stack Overflow said, hey, I've been running benchmarks to see how everything goes, but I noticed that when I'm doing group by tests, MySQL 8 showed 10 times better performance. That's a significant better performance. Luckily, one of our engineers, Oystein Grovlin, came out and said, MySQL 8 uses a new storage engine for temporary tables. Before, temporary tables had a memory limit, and they kind of had to do some other stuff, and if it hit that limit, had to copy everything over into InnoDB and do some other machinations. Very expensive, lot of overhead. New temp table is amazing. Does a lot of things a lot faster. So please upgrade. Besides the obvious security and bug updates, there are some major improvements that you've been waiting for that are in MySQL 8. The big one, and the reason we jumped from version 5.7 to 8 was because of the data dictionary. Previously, all the metadata you had was in little bitty files. So if you ever went under varlib MySQL and did an ls-lar, saw a bunch of MYIs, MYDs, IBDs, da-da-da-da-da, that was the metadata for your database. Wonderful system when they came up with it 25 years ago, hasn't aged very well. You always run into the problem of the junior system admin going in there and cleaning up the directory and deleting something or blowing it away, or an inode having problems and suddenly your database is not working. So we put all the metadata within the database. The InnoDB storage engine, which holds all that information, is very good at crash recovery. And keeping the metadata in there lets you have a point-in-time recovery. So with the central data dictionary, it lets us do a lot of things and lets us make a lot of changes that you're just now beginning to see with version 8. The biggest thing that you're probably going to notice is that we now have instant add table, which is something we picked up from Tencent in China. Now, the biggest change for you as developers is that you can now have millions of tables within a schema. The bad news, you can now have millions of tables within a schema. I know this is going to bite someone someday fairly soon, and I'm just waiting for it. Because those of you with gray hair might remember Microsoft told us at one time that all you need was 640K of memory to program in. You wouldn't need any more than that ever, ever, ever. Like I mentioned earlier, Tencent Games gave us some interesting code for instant add column. For a long time with all the .frm files and all that, it was hard to synchronize updating tables. This is a nice little patch, and we're building on that. You'll hear more about that in the next 2 weeks or so, some other announcements. Also, there used to have a problem called bug 199, where the InnoDB storage engine auto increment would get confused. We fixed that. For most developers, that was something you ran into every so often, but it was enough of an annoyance that we are glad to announce that we fixed it. Cats. By the way, I was very interested when I saw an ad pop up on my Facebook for the cat cafe around here. Has anyone gone there? It's interesting. You actually book time to go sit down and have cats crawl over you. My aunts could have made a fortune. So what am I talking about with cats? Well, unfortunately, it's not this purring little buddy here. It's contention-aware transaction scheduler. Those of you who are really into databases might have seen this paper come out a couple of years ago from the University of Michigan. And basically it was pornography for our core developers in the scheduler department. Basically, they figured out if you have hot rows, hot columns, hot tables, some heuristics on how to free those up for other access. The brief summary, so you don't have to go out and read all 25 pages of that link there, is that if you have something that's highly contended and someone keeps grabbing it more and more resources to get to that, give it to them early like a toddler and they go away happy and they release it sooner. So it gives a better throughput on your data. Indexes. Indexes are great. They let you go right to the record or records you want. You don't have to read the entire table. That's called a full table scan, and DBAs hate that when you have unnecessary full table scans. It's very expensive, very slow. Indexes are great, but there's a maintenance cost. Every time you do an insert, update, or delete, it costs you. We introduced histograms, which I recommend you run at slack times on major changes on data that really doesn't need to be indexed. But when you go out and run explain on your queries, you find out that it's kind of doing a lot of reading trying to figure out what it needs to get. So histograms give the optimizer the statistics it needs to figure out where to go grab your data. This is very much like a GPS system on your phone or in your car. You want to get down to Polk Street, you plug in the information, the GPS knows how to get to Polk Street from here. Unfortunately, sometimes historical data isn't great, so you may not know that there's a traffic outage or some other blockage on your main way. But basically, the optimizer wants to know how many rows there are in each table, how many distinct values, their cardinality, and how is the data distributed in those columns. Well, with histograms, you get that without the expense of indexes. Now, here's a histogram for some class scores made up for someplace, score on a final exam. And you see that the folks in purple are the 80 to 100 grades, green in the 60 to 80. That's one way of doing a histogram. So use histograms to give an approximation of the data distribution to the optimizer. The optimizer uses this when it's breaking up the query plans for your query. Now, MySQL wants to re-optimize every query you send it in. Oracle, you can lock down the query plan, which is why Oracle DBAs traditionally got a lot of money because they had to monitor all that, and when the data patterns changed, they had to go out and manually change that. MySQL wants to optimize that every time. So the syntax is you use the analyze table function, and you tell it to update the histogram on whatever column you want to do. And if you want to get rid of it, you just use analyze table with drop histogram on the column name. And you can do multiple columns. Invisible indexes. This is also something for the optimizer. In the past, if you had a query and you're not sure if the index was useful for you, you'd often just blow away that index, run explain on that query, only to find out that, yes, you really needed that in query. So you go to rebuild that index, and it might take seconds, minutes, hours, days. It wasn't an efficient way to do that. So with an invisible index for your session, you basically declare the index invisible. You rerun explain, and it tells you how that query works without that index. Now, if you need it back, turn the index visible. If you don't need it, you can actually blow it away. But I recommend if you're going to do that, blow it away several days later just to make sure no one else is using it. Also, something else we're seeing a lot of now is replacing many-to-many joins with the JSON data type. Many-to-many joins are very, very expensive. For years, I preached that you should at least go to third normal form or better on your databases. But with the new JSON data type, with the ability to store a lot of information in JSON documents, you can get away from that. That saves you reads. Whoops, see, let you take your picture. Thank you. By the way, the slides are available on slideshare.net. This also gives you mutability. A lot of us are in situations where we don't know what our data is going to look like a week from now, 2 weeks from now, sometimes not even an hour from now. And without having to go back and re-examine all your tables and plan for it, it's nice with a JSON column just to be able to shove that in there. And using embedded arrays to store relationships is very efficient. One of the things you can do, this is a very poor example, but it's very obvious, is if we're trying to get some information from a couple tables for a customer, we get the customer ID and then go out to one table and get their address, another table for their phone, another table for their payment information. That's 4 dives into the data to get that information versus doing it all with one thing. You got a question? Or? Okay. Resource groups. Recently I was in the UK testing this with a financial institution. Very, very interesting concept. What you do is you assign certain virtual CPUs on your box to certain groups. You can control what those groups have for resources or priorities. The server at startup determines how many virtual CPUs you have, and you allocate those CPUs to a certain type of processing. For instance, you have batch processing. You have something that's coming in, so like you're scraping something off an email request. You create a resource group called batch, assign it to 2 CPUs. This example is assuming that we have at least 4 CPUs, and give it a thread priority. Thread priorities are I think run from 0 to 20 or 1 to 20. Something like that. So if you have some processing that runs during the day that's not very important, set this up into another resource group. Multiple resources groups work really well. I was testing on a 48-core box. We had 5 different resource groups, and it was real interesting seeing how you could play with the flows of data to give other folks great response while slowing down others. To use a resource group within your SQL query in a comment, you put in a resource group and then whatever group it is. The optimizer realizes that and schedules that for those CPUs. Autonomy. Interesting cartoon here. Databases are getting better at realizing what their environments store. Part of the interesting thing of seeing the interplay of people moving from dedicated hardware into the cloud and to virtualized servers is that the databases have to be more on top of what they're actually running on. So you're going to see, especially right now with the big Oracle database and a little bit later with the MySQL database, that the databases are going to do a lot of self-tuning to help you out. The payoff is less human labor. You don't have to have someone babysitting the server. Less human error, no one to fat finger things. And you don't have someone doing a lot of what I call gross manual labor, going out and having to reassign memory, make complaints about stuff. JSON updates. MySQL 5.7, which has been out for 3 years now, the most popular feature in that was the JSON data type. That gives you roughly a 1 gigabyte payload within a column of a row in a table. We have roughly 30 functions to support the JSON data type. By the way, if someone asks a really good question, I have a book that I'll give you, written by me on the JSON data type. It's also the foundation for the MySQL document store, which is a NoSQL JSON document store. I'll touch that a little bit later. When 5.7, when we came out with it, we were kind of stumbling around. And if you did an update, like you changed one value in your JSON document, we had to rewrite everything out. The optimizer now understands how it works and it does a partial in-place update. Much, much faster if you're keeping a lot of data in JSON. We also added a whole slew of JSON functions. JSON pretty, do I have a slide of that next? Nope. JSON is designed to be human readable. The only trouble is when you have a large document and you print it out on a command line or in a little GUI window, it's all strung together, hard to read. This is a pretty printer. The JSON array and object aggregators are wonderful. If you have arrays of JSON arrays or JSON objects and you want to stick them all together, it's wonderful. If you have non-JSON data you need to output in JSON, these are the functions you use. Makes it really slick for outputting JSON data. Also, we had some changes due to the standard and popular thing with the way we were merging JSON documents. I won't go into too much detail on that. These are a list of the functions out there that we offer. We don't have a course on that. Now, the most interesting one is JSON table. Let me get a drink. Pardon?
I was just reading out loud that it's temporary relational table.
Yeah, it takes your schema list data and it turns it into a relational table that you can use to process your non-relational data as relational. So here's a rough example within a query. Let me make that a little bit better. With JSON table, the first argument you give is the column, the JSON document that you're using. And then you say, I'm going to take the entire document. That's what the dollar is. It's like a this operator. And you're going to create the columns, country name and India year. And what you do is for that document, you look for the key of name and shove the value into a car 20 and the value of independent year as an integer into that value. And then you can come down and do your where clause on the data. Very slick. The manual page is a little tricky, but it's really interesting if you're doing a lot of stuff with unstructured data and you need to do something structured with it. Sys-schema. Sys-schema is a bunch of views and stored procedures on top of the performance schema and the information schema that we've had in MySQL for the past several releases. The Sys-schema is written by one of our engineers to answer common questions like, what are your top 5%, highest 5 processes by runtime, tables running full table scans that you might want to put an index on. I'll also tell you which scans are running without indexes, which ones have redundant indexes, all that sort of stuff. It's a way, very interestingly and very cheaply, to go out and find out how your system's performing. How do you get this information? Well, you can either use the command line interface to get to the schema, or you use MySQL Workbench, where we have a GUI that will walk you through all these various reports. Here's one, statement execution times for each user, so you can monitor who's doing what and to whom. Set persist. If you're working in a Docker environment or in a cloud environment, set persist is a godsend. In the past, I'd make a change on Tuesday to a server, he'd make a change on Wednesday afternoon, and he'd make a change on Friday afternoon. Sunday morning, for some reason, everything crashes, and the system reboots, and it isn't running like it was. You can't find me. He's on vacation. He's not sure what we did. So he redoes his change, can't tell what's going on. What set persist does is it writes all this information out to a file. Oops. When it reboots, the system runs through all the configuration files, and then MySQL d.auto. And anything that was done, any changes made with set persist are in there. So now you have not only the command saved, but it has a timestamp and who made the change. New shell. The MySQL shell that you're all probably used to is 20 some odd years old. It's getting a little creaky. And we realized that we were going to do a whole bunch of new stuff. And part of that was the MySQL shell. It's part command tool, part management tool, cluster tool, and all that. Now, the first thing to notice when you run this is that it now has multiple colors. It has 3 modes: JavaScript, Python, and SQL. So if you need to manage your data, you can use it with that. But one thing we've done is we're really forcing security on you. You now have a SHA-256 encryption for authentication. As I mentioned earlier, your bosses are really buying a lot of security. This is very nice. So we set up TLS for you. Next thing to notice is that everything else, all the data by default, is supposed to be UTF-8MB4. This is done for 2 reasons. One, JSON support, and B, is we're seeing a lot of people in Asia pick up MySQL. We support the GB 18030 character set, which I think is the official character set of the People's Republic of China. And also, it lets you have all 4 planes of the Unicode support. Big happiness there is now you can put the poop emoji in your data. What's real funny is I was talking to someone, their company is actually assigning you an emoji for part of your sign-in screen. So you have to figure out how on your keyboard, on your laptop, how to generate that emoji to be able to log in. Yeah. One of the neater features is if you're running MySQL 5.7, you can type in util check for server upgrade, and it will go out there and evaluate your server and tell you you're misusing this reserved word, you have a key that might be too long when you convert it over to 4-bit UTF-MB4, what file system, what tables you have to upgrade to UTF-MB4, things like that. Also, if you have things you want to change, you can actually have the shell configure that instance and reboot it, or reboot the server. And also you can create a NODB cluster. This is our high availability master-master active-active clustering for high availability. You manage this all from the shell, and with 5 commands in about 2 minutes, you can set up a 3-node cluster that's highly available and fault tolerant. Part of this work is thanks to Google protobufs. Very interesting way of sending stuff to distributed systems. The benefit for you all is that it makes SQL injection much, much, much harder using the new protocol. The parameterized information is, here we know we're going to send off an identifier, and we know it's going to be a string, and it knows to watch out for someone trying to put too much stuff in there. Okay, the MySQL document store. We saw the growth of a lot of NoSQL databases and started analyzing it, and the main thing that people wanted was schemaless data. So we came up with the JSON data type, and that lets you put in data without having to sit down and create a schema, set up foreign keys, worry about data types, or normalizing data and all that. It's flexible. You can do whatever you can do in JSON. It's close to the front end, which is, we're seeing a lot of stuff being done in JavaScript, and it's fairly easy to learn. Now, traditionally, DBAs saw data like you see on the left, where you have tables that have a relation to another table, that have a relation to another table. Most of you all see data roughly like this. So we're trying to give you the best of both worlds, where you can access the same thing at the same time on proven MySQL technology. Once again, it gives you a schema flexible format, uses our new API. Once again, the document in every, you can have multiple columns in a row, but each column is going to be roughly a gigabyte. And the new API lets us use a modern programming style instead of having you embed SQL into your pristine, beautiful PHP code. We have connectors for most popular languages, working with a couple others to get it out there now. It works very well with our new shell, which also has command completion. And you now have a high-level session concept that lets you scale from a single machine to multiple servers. So as your application grows, and you got to use something like NODB cluster, your application doesn't change. Something else that I don't have on here is we now have the ability to have several asynchronous queries go out, and your program keeps running, and it gets notified when the various queries come back. So here's an example. Connect to the server, and we tell our session to create a schema. We're going to call it docstore. Use that schema, and now we have a pointer called DB that we can use to get into there. This is an example using the restaurants database collection from the Mongo world. What you can do is, if you want to read more about this, Giuseppe Maxia, a data charmer, has an example on how to export the data from Mongo, or you can just grab the example file. And you fire up the new shell. Here I changed it from JavaScript to Python mode. Import the JSON and regular expression libraries. Open up the collection, and for each line, plug it into the database. db.restaurants.add, add in that record, and then execute it. So first time I saw that, I was very impressed. So after you do that, you can just do restaurants.find. The only trouble with that, there's 25,000 records out there. It's easier just to show you how that stuff gets in there by post-pending limit, find.limit. I think that's limit 1, gives you the record. Now, if you don't want all the data, you can specify using the fields operator the particular fields you want. You can also find on cuisine equals Italian and with those same fields. And you can also do logical operators like and, borough, not equal, Manhattan. Doing that in Mongo, similar syntax, but I think theirs looks a little messier. Let's see, what are we doing here? That's basically the same thing. I'm not sure why I have that slide in there. Now here are the railroad illustrations of what's going on. We're trying to make the CRUD as easy as possible for you so you don't have to suffer through SQL if you're not an SQL programmer. Big benefit here is that if you're working with someone who's working with the MySQL document store, you're doing PHP, they're doing JavaScript, and someone else is doing Python. The functions all work and look pretty much the same. So we have add, modify, remove, and find. And you get all the operators you're used to having, like group by, having, sortings, limits, offsets, and you can bind variables. We also have a hierarchy within the shell and within the document store to organize your data so that you can access whatever level you want. And by the way, it also works with relational tables. So if you have something that's unstructured in a collection and you need to tie it to a table, you can do that. Now we did rename the CRUD functions for the SQL world. We named them insert, select, update, and delete, which maps to the SQL world. We also support transactions. Here's an example where we're trying to add a record where the name is Renee. You see it out there. Notice at the top we do a start transaction. We do a session rollback and goodbye Renee. So, as I mentioned earlier, what happens to your old SQL tables? Well, they're still out there, and behind the scenes, it's the JSON data type. Now, this new protocol and all that is not an object mapper. We're using Google Protobuf protocol to talk to the server with the new protocol to handle all this. This is the lovely diagram to show you what we're expecting this to look like. Here's your traditional where you have the MySQL connector. Hopefully you're using MySQL I, PDO, or something like that. Hopefully not the old MySQL connector because that's deprecated. And on the other side, using the new protocol, you have whatever connector you want, and it goes through the X plugin right to the optimizer. Currently, for PHP, it's a PECL extension. We're trying to get that upgraded so it'll be easier. So if those of you who aren't used to building PECL extensions could do it. It's 5 commands to build it, but I think that's like 4 commands too many. If you do a describe on the restaurant, you'll see that in the document store we have 2 fields. The document is in a JSON column, and we have something called _ID, which is var binary 32. Stored and generated. I'll talk a little bit more about that in just a second. If you do show create table, you'll see the same information in a slightly different format. Once again, doc is a JSON column. ID is var binary. What we do is when you input the document, if there is a field in there called _ID, we extract that and put it in the value into here. If you don't have one, the server will generate it for you. This has some information in there. We're thinking about using UUIDs, but UUIDs have some problems, most notably not advancing monotonically, which means you end up with gaps in your records, which you don't want for primary keys. The generation of these actually has some information in there on what server generated it and when it was time-stamped. But I'm not going to go into detail on that. If you really want detail, grab my book, or I can point you to some docs online. Now, how does this new document store compare to what you're used to in SQL? Well, document store is create collection my collection. In SQL, you're going to have to type the create table and get your fields out there for you. If you want to add a record, it's add and then the JSON document with a key and value. The SQL is this. Most programmers, ironically, are lazy typers, so I have a feeling a lot of you will enjoy the one on the top over the one on the bottom. Once again, doing a find where we're looking for a test with a value greater than 100. The SQL is obvious if you've been writing SQL. Unfortunately, not too many folks are getting any formal training on SQL these days. Now here's an example where we're going to go through and we're going to create a generated column and we're going to extract the borough records into a column named borough. And fairly simple to do. Now, if we want to create an index on the cuisine, it's fairly simple. You create index and you have some flags, required false. If the record doesn't have a cuisine record, it's not going to kick it out. And we're going to describe it as, we're going to say it's a type text 20. Now, if we run through there and do that and then look at the table afterwards with a show create table, you see how it is actually goes out and does the extract on that information and stores it in this lovely little variable name here that's so easy to repeat. Now, sometimes when you're doing creation of indexes, they can get messy. In this case, we want to go out and create an index on cuisine, and we want it to be a varchar 20. Well, that's okay, but in this case, the data is too long for column. One of the records has more than 20 characters for the cuisine name. So what we can do is we can specify that we're going to take the 20 left characters of that and create an index. And there's the information. Well, what good does this do me performance-wise? Well, once again, indexes to the rescue. If you see here that when we run this query, here I'm going to explain on select doc.name, $.name, and the cuisine and the borough from restaurants where cuisine is equal to Italian and the borough is equal to Brooklyn. You'll see that it's a full table scan. It has to read everything in that table. And that's 24,890 records. Well, if we want to clean that up a little bit, we install our index. And we drop from 24,480 down to 192 records that have to be read. Much, much, much faster. Now, in New York City, as in California, you see the restaurant grades. Now, here's in the document, we have a series of grades from the restaurants. And as you see in this array, we have various objects. Here's March of 2014, September 2013. So we have several records there. Parsing through that in a JSON document can get messy. What you can do with us is you can use it just as an array. Grade 0 will give you the first record, which is March of 2014. Or you can get the last one by putting the value last, which is 3/2011, 3/2011. And you can also do things like, okay, give me 1 to 2, first to last, second to last -1. Gives you more flexibility walking these arrays that are programmatically a pain in the butt to do so by hand. Once again, you can also use JSON table. So we're going to create columns, name, shove it into a car 40, and be able to treat the unstructured data as structured. And once again, that's how the thing maps out. Now, one of the things we can do that you can't do in, say, something like Mongo is structured statistical analysis. Lets you dig in deeper to your data without having to go out and try to do this in your application. Big example here is using something called a common table expression. If you've ever had to write a subquery in MySQL or any other SQL-based language, they're a pain in the ass. Anyone run into a problem with an uncorrelated subquery in their life? It's, I know your pain. Common table expressions let you write subqueries very easily, and they're very easy to understand. In this case, in green, our subqueries now select the name from the document column and call it name. And we can actually go through and call that. we call that entire CTE1. So we can call that kind of like a subroutine to get that. We also have something called a windowing function. Previously in SQL, if you're doing statistical analysis, you could do it for one line or a group of lines. There was no way to really do interesting subgroups. Well, with windowing functions, you can partition your data by interesting alignments. That can be a date, department ID. With dates, you can do something like, hey, 1 week previous to today. So if your boss asked you, how are we doing financially this week, you'd be able to do information like that. The windowing function here is in blue. The keyword is rank. So we're going to partition the cuisine by average score. So in this query, we're going to find out by cuisine which restaurants have the highest score. Trying to do something like this outside of what we're offering is really, really messy. And here you can do it in one query. So the document store gives you the best of both worlds, gives you all the stuff you're used to in a relational database, gives you all the flexibility of a NoSQL database. Locking changes. This is also going to make your lives a little more interesting. Skipped, locked, and no wait. Pretend you're a ticket master and you're selling tickets and you want to get seats where seat number is between 2 and 3 and not booked. Well, someone else is out there before you and they've locked those records. You don't want to sit around and wait. If it runs into locked records, this will skip over whatever records are locked and give you what else is out there. Now, if you go out there and all the records are locked and you don't want to wait, you add no wait, returns instantly. So if you run your query and you see there's no records out there and then it came back with a notice that it couldn't get anything and did not wait around for you, you know what's going on, you try to go to another set of rows. So, conclusion, and I do have one. Big changes in the database world, especially MySQL. Something we're doing, we've gone to a CI model. We are going to have another release in the next 2 weeks or so. You're going to see a lot more new features. It used to be that we used to release new features only with big releases. We have too much stuff going on and it was too messy to do that. Our software is smarter about its environment, and one of the things we're doing with that in combination with the constant integration is you're going to see a lot more new features come out as shared objects or plugins. Or if you want that feature, you install the shared object, which is install shared object name and a path to the shared object. You don't like it, you uninstall it. We're also giving you more powerful SQL with the new locking features and the common table expressions plus the windowing functions. The data dictionary is going to be a big change for a lot of us now that you basically have unlimited number of tables you can have in a schema. By the way, there's a guy named Alexander Rubin from Percona. He got bored at 40 million. That's a lot more patience than I have. With the document store, you get the best of NoSQL and SQL worlds, and we're trying to give you better command and control over everything. By the way, if you're interested in the JSON stuff, please buy my book. And with that, let's do Q&A. So what questions do you have? No questions?
What?
Oh, yes, sir.
What was your book called?
I'll tell you what. Make it simple for you. There you go. Enjoy. Okay, any tougher questions?
So do you guys foresee like MySQL and NoSQL just like living together? What's the, I guess, the business plan there? You're not thinking about taking over MongoDB, I'm assuming. So it's kind of like a...
What do I see NoSQL and SQL doing?
Right, because...
Find what Caliban's gone so we can catch up. When I started in computers, the big battle was, if you're in the IBM world, you coded everything by the EBCDIC standard. That was the way God and IBM wanted to do that. Everyone else went ASCII. 40 years later, no one does anything in EBCDIC unless you're a hereditary IBM shop. So things kind of switched over. My personal view, not representing Oracle on this, I think 15 years from now, NoSQL and SQL will be a great question for PHP Jeopardy at some conference, but I don't think it's really going to matter. Meantime, I've seen all the SQL vendors really add a lot of NoSQL features. Now we're watching the NoSQL world trying to add things like transactions. Mongo just came out with transactions. They're still fumbling around a little bit. They've done a wonderful job. I don't know how stable it is, but I know folks like Jeremy, who was here earlier today, are working very hard on that. So my guess 15 years from now, not going to be much of a difference.
Okay.
So
no, I mean, not ideas about like making the non-structured data is more like structured in terms of introducing the concepts like foreign keys, which don't really exist and stuff like that.
yeah, it's kind of hard to do foreign keys on unstructured data.
Right.
Well, I think we'll do something. I think you'll see something like a hybrid of what we use for generated columns, where if you know your unstructured data, 90% of the time it's going to have something out there called ID that will grab that for the primary key. Other than that, the engineering gets real messy, and we don't know what's around the corner. So,
I can imagine.
yeah.
So the underlying data structure, you guys think that it won't become a JSON type document? You just represent it as a kind of like an SQL eventually or no?
JSON is easy for humans. It's hard for computers.
Right.
And to tell your database system that you're now going to do whatever you've been doing, but now doing off JSON is a lot of workload. So I think for the foreseeable future, probably 20, 25 years until quantum computing really comes out strong, you're going to see structured data at the heart of most businesses.
Still, all right.
So,
Got it. Thank you.
yes, sir.
Are all these things available in all editions?
Yes. I didn't mention anything today that's not in the public free community edition. If you want to talk the enterprise edition, I can talk about some of that. By the way, if you ever get the source code of both of them together, hold them to the light, the only thing that really changes are the copyrights lines. The core server is the same between the two.
And then will that flow into MariaDB?
MariaDB is based on MySQL 5.5, which ironically, if you're running MySQL 5.5, we're end-of-lifing that for support at the end of this year. They're trying to backport some of our features, but as we've advanced with things like the JSON column store and the data dictionary, I don't think they have the resources to be able to grab all that. So they're now trying to get our SHA-256 identification because a lot of folks want to run their client software with our databases, and you can't do that right now with theirs. So, come on, you got the tough question.
Last question.
Do you or anybody else know if Docker supports the document store?
Ironically, when Docker came along, there was the official Docker MySQL container, and MySQL had the MySQL official Docker container. The Docker folks said, if you guys are going to do the job that you're doing now, we're going to drop our version of your stuff and let you guys do your own containerized Docker stuff. Yes, if you go out and do the MySQL D:8.0, it pulls down the latest and greatest version.
Yeah, I was actually meaning Doctrine.
Oh, Doctrine. Oh, I'm sorry. I watched the talk earlier today with Doctrine. I don't know what their development schedule is. I know another ORM that's working very, very hard to get the document store stuff going, but I don't know specifically about Doctrine. So, any Doctrine folks in here? Or? Okay. Okay, and Sophie said that was the last question, so if you have any other questions, I'll be outside for a little bit. And thank you all for coming out. Be sure to thank Sophie and her crew because they've done a wonderful job. Wonderful food, by the way. That's amazing for these PHP conferences. Have a good day.